Hello and welcome to my Pre-Algebra review series. This video covers Chapter 9, Section 1 of your Big Ideas textbook, titled Scatter Plots. By the end of this video, you will have reviewed recent lessons regarding scatter plots, interpreting scatter plots, and identifying data relationships. Please leave a like if you find this video to be helpful. Give your classmates a heads up too. It'll be more than likely help them, and it'll certainly help this channel to be seen by more students. If you'd like me to cover any of these topics in greater detail, please leave a comment in the comment section below. I read them and do my best to address each as time permits. Please subscribe to my channel and ring the bell icon to be notified every time I release a new video. Thank you. Let's do some math. Key idea: scatter plot. A scatter plot is a graph that shows the relationship between two data sets. The two sets of data are graphed as ordered pairs on a coordinate plane. Example 1. Interpreting scatter plots. The scatter plot to the right shows the amount of fat in grams and the number of calories in 12 different restaurant sandwiches. So let's go through some questions and answers here. How many calories are in the sandwich that contains 17 grams of fat? Well, in our chart, the fat grams are plotted along the bottom, the x-axis down here at the bottom, and the calories, as you can see, are plotted against the y-axis. So all we have to do is draw a horizontal line from the point that has the x value of 17. So we're going to go up, and we're going to say, here's 17. It's right here between 15 and 20. And we're going to go up till we get to the 400. And right there, that's the point right there. We're going to draw it up to here, and we're going to see there's the point right there. 400 calories. That's where it says. So the sandwich has 400 calories. How many grams of fat are in the sandwich that contains 600 calories? Well, let's find 600. Go across and find that point. Here it is right here. And then we're going to look straight down for the x value, and it's 30. So we're going to say that the here it is, drawing a vertical line for the 600 calorie sandwich crosses the sandwich has 30 grams of fat. Right there, 30 grams of fat. Let's do the next one. What tends to happen to the number of calories as the number of grams of fat increases? Well, as we look at this, we see here's grams of fat increasing from left to right. That's the grams of fat increasing. And what's happening to the data? As we go more and more right, the data generally goes higher, does it not? Okay, so we can say that as the number of grams of fat increases, the number of calories increases. Okay, exercise number 1. This is for you to do on your own. I brought the plot from the last slide so that you could see the data. I put it right here, and it's the same data we were just looking at, but you can use it for your answer. It says, what if the sandwich has 650 calories? Based on the scatter plot in example 1, how many grams of fat would you expect the sandwich to have? And then explain your answer. So why don't you go look at it and come on back when you're ready? Okay, I'm sure you're back now. So what do you think? It says if a sandwich has 650 calories. So let's find 650. Here it is right here. And we can go across on that line all day long. And we're going to get close. There's some data right there, very close. We can say that we expect the sandwich to have how many grams of fat? Well, if we follow this line right down all the way down to here, we're going to say that it should have about 33 grams of fat, I would say. 33 grams fat. Okay? And why? Well, because if you take the 650 and go across till you hit, it's a spot that's on the graph. It's in line with the rest of the data. It's not a outlier, it's not some odd way wazoo crazy dot. It looks like it's like the rest of them. So I would expect that if I had a sandwich that was 650 calories, it would come down here and it would meet somewhere in this 33 fat gram range. So that's what I would say. It's in line with the rest of the data. And it seems to fit the pattern. Okay. So another key idea, relationship types. Well, as you see, there's some patterns in front of us on the page here, and these are types of relationships. So it says a scatter plot can show if a relationship exists between two sets of data. Well, if you look at the first one here, the data is all clumped around a line, some kind of a line. It's a line that goes like that. It seems to be going from left to right, from left to right, it's increasing. So we call that positive, okay? All the points lie close to the line, okay? And we're assuming that if the number went out, X went out, the farther it goes out, the higher the line is going to go and the more the dots will relate to it. So we call this a positive linear relationship. And it's linear because you see it pretty much is straight. It is a line. The points lie close to the line, and as X increases, Y increases. Those are all the things that make a positive linear relationship. The next one here, the line is going down from left to right. Okay? We call that a negative linear relationship. And again, it's linear because it all seems to fit on a straight line. The points all lie close to that line somehow, or generally, and X increases, Y decreases. So as X increases, Y decreases. So it's therefore a negative linear. Now you're going to see something a little different. So this is a nonlinear relationship. The data points all line up very close to a line. Here's the line. It's something like that if I can draw it. It's something like that, all right? It goes up there. The points lie close to the curve. That's a nonlinear relationship, and it's more than likely a quadratic, like an x squared relationship of some type. And then there's the no relationship. If you just look at these dots, they're all over the chart. There's no relationship to them. No matter where X is, it can have a high dot, a low dot. It doesn't matter. There's no relationship. So those are generally the kind of relationships we have. Positive, increasing, right? Linear, negative, linear, or decreasing. And this one happens to be, says nonlinear, but it's a positive nonlinear. If it was curving down, it could be a negative nonlinear. Okay? So in example 2, identifying the relationships, it says, here's problem A, a television size and price. The points appear to lie close to a line. As X increases, Y increases. Okay, so the scatter plot shows a positive, see here it is, let's look at it, a positive linear relationship. Well, there's more to talk about here, but the line is generally, is this going or not? Oh, going like that. Sorry about that little mess. Maybe I can clean that up a little bit. My pencil fell out of my hand. I'll hopefully I can do that again. Okay, it's basically the best line I can draw. So it's basically a line. It's positive. As X increases, Y increases. There is an outlier. An outlier is like, here's the line, right? We're looking at the line. This dot right here, we'd call an outlier. It's outside, so you can include it in the data. Sometimes, depending on your data set, you can throw outliers away. Maybe you can throw out the two farthest outliers. So it depends on what you're testing and how it's working. It also shows that there's a clump of data all clumped down here at the bottom, where the rest of them are all spread out pretty good. Here's 4 of them right in a row. And then also, there appears to be a break in the data. These spots right here should have probably maybe filled that in if it was truly as linear as we'd like it to be. But so this is showing that there's no value for X in terms of television size in this range that has a price that's in the $500 to $1,500 price range. And then for B, age and the number of pets owned. The points show there's no pattern. So this scatter plot shows no relationship. There are no obvious outliers, no gaps of clusters or data. It's just a bunch of dots. So it doesn't matter how old you are, the number of pets you have, 4, 3, 2, it just varies wildly. There's nothing that says, well, if you're 20 years old, you're going to have 1 pet. And if you're 30 years old, you're going to have 2 pets. None of that shows up in the data. This is generally non-relationship. There's no relationship at all here. Okay, exercise number 2 on your own. We'll let you figure this out on your own first. So make a scatter plot of the data in this chart here and describe the relationship between the data. Is there a line? Are there outliers? That type of stuff. And this is what this is on the x-axis, going horizontally, the time studying for a test. And on the y-axis is your actual test score. So they're trying to decide if I study longer, will I have a higher score? And is there a relationship at all to it? We're going to see if we can find that out. So I provided a chart. It's hard to see the numbers. You can have to make up your own. But the bottom goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm going to say those could be 10s, right? 10, 20, 30. Because it's 20 minutes, 30 minutes, 60 minutes, 90 minutes. You can kind of play with that. And then going up, it's 200, 400, 600, 800. Well, you could call that 20, 40, 60, 80, 100. Okay? So obviously our data is going to be in the lower half, somewhere in the middle of this chart. But play with it, do the best you can. And then when you come back, I'll plot out a few, and we'll just take a look and see what the data seems to show. Okay? So go ahead and try it. Okay, now that you're back, I've put in my numbers. And of course, it's not perfect. Just like I was telling you, it's not really going to be perfect because this chart is kind of hard to see in these little small numbers, but sorry about that. But I plotted them out. I went to the very first one. I have a study time of 30 minutes and a score of 80. So I went over here to the 30 down here at the bottom. Where's my pen? Somewhere. Here's my pen. So I went down here to the 30, and I went up to 80. Well, here's 80 right here, 800. And this bottom, there's 2 dots right here, by the way. So the bottom dot is where that data is. And then the next one was 2074. So I went down to 2, which is 20. And 70 is in the middle, so 74 is about the middle of that. So there it is, right in there somewhere, okay? And I did all of these. There's 2 dots here, by the way. This one here is 90, and there's only 1 dot for 90, and it was 70. Oh, wait, there's a 75. Oh, I'm sorry. I'm going the wrong way. There's the 90 right here, 90. So here's a 90, and real close up here to the 100 is a dot, and for the 97. So you get a pretty good idea. If you do all the dots like I did, you should be able to see a relationship maybe. So what is the relationship? Well, I can say that there's a little bit of clustering right here. There's clustering right here around the 30 minutes of studying and the score of 80. So it seems like people scored 80 that were doing like 30 minutes. There's a little blank, a little spot in here between them, a little gap from here to here. Maybe that's where one of them, that dot should have been, meaning that, oh, geez, if this person had studied 35 minutes, they would have had a higher score, but it didn't work out that way for them. There is an outlier way over here. This person studied for 120 minutes and only had a score of 70. It's kind of an outlier. So if you were trying to say generally when people study for the test, this is where they would fall. So in theory, if they study for 120 minutes, they should have at least had the 100, but it would have maybe been higher than that if it was in the line. And it is kind of a line. If you look at it, it's maybe a little bit of a curved line, but it kind of goes like that, It's just my freehand drawing, but there are tools that can do that a lot better and do perfect lines. We'll probably see it in the next section in something called lines of fit. But right now I'm going to say there's a line. There's some gaps. There's some clustering, a little bit of clustering, an outlier to look at. Okay, is that good?